All right, welcome to our first video of our transformations in section 3.5. We're going to look at vertical and horizontal shifts. Oops, I'm in the wrong section here. Okay, welcome to the first video of our transformations of functions using our basic function graphs and knowing how to graph them, if you will, just by doing the transformations of shifting up, down, left, and right. So the first ones we're going to look at are vertical shifts, up or down. So where you see the f of x, this will be one of your family or library of functions. So for our first couple here, we're going to use the square function, x squared. So I'm looking at f of x plus some constant, or it could be minus some constant. So I'm going to graph two of these here. Right now, I have my basic U-shaped parabola x squared. There it is. I just plotted those few points. Now, what I want to graph is y equals x squared plus 2. Now, because I'm on the outside of my basic function, anything outside of the basic function is going to change your y coordinates. So what I'm going to do is I'm going to go over to my graph. I'm going to find perfect points. Those are the ones that are on the corners of your square. So I see 5 of them. 1, 2, 3, 4, 5. Yes, they can be at the tip of the arrow. That's fine. So all 5 of these points are going to move up 2 squares. So this point up 2, up 2, up 2, up 2, up 2. There they go. I shifted them up 2, redraw the graph, and there is x squared plus 2. My next example, I now have x squared minus 4. Again, the minus 4 is outside of the x being squared, so this affects the y coordinates. Okay, take those 5 points and slide them all down 4 squares. Come back here, I wasn't done with you yet. Slide them all down 4 squares, and that's the graph of x squared minus 4. The shape of your basic function does not change. We're just relocating all the points up or down. Now, since all my changes were after the x being squared, what I like to call outside the function, or after the function, if I want to shift left and right, everything has to happen inside the function, or before I square the x. So now my function, f of x minus h, so if f of x is x squared, I'm going to be adding and subtracting an h, some constant, to my x before I get to square it. So this is inside the function. Notice it's inside parentheses, grouping symbols. So x plus 2, that being squared, we would think, okay, plus 2 would go to the right 2. We find our 5 points. You think about going to the right 2, but that's really not the case. When you're on the inside of the function, it's an opposite effect. So outside plus 2, you would move everybody up 2. Inside, it's opposite. And what I like to tell students is I said, look, take what's ever in the binomial, set it equal to 0, and solve for x. X will equal negative 2. Now the negative sign tells you which way to go. Left. How far? The 2 squares. So they all go to the left, 2 squares, regraph it. Remember, we are shifting left and right. So if you look at the origin, 0, 0, I don't want the y-coordinate of 0 to change. So in order to square a number and get the y-coordinate of 0, I need to turn the inside of the parentheses to 0. Well, if I'm adding 2, then my x better be a negative 2 so they cancel each other out. And that's what causes that opposite effect. So if we have x minus 4, that binomial being squared, now all my points are going to go, set it equal to 0, add the 4 over, plus 4, positive 4 to the right, 4 squared. So we'll take our 5 points and shift them all to the right, 4 squares, and reconnect it. Again, looking at the origin, the y-coordinate is still 0. So what do I have to put in for x that will give me a 0 here? So 0 squared is 0. I'd have to put in a positive 4. And that's our shifts, vertical and horizontal, up and down, left and right.